Hi, this is a video for the MAT 2018 question 1 part I. So my attention is first drawn to obviously the equation. We can see that what we've got below all appear to be parabolas with various sorts of reflections or rotations or translations. Um, But if we start off by really just focus on the equation, generally the first thing I try and do with any equation like this is see if it is has any lines of symmetry. So, for example, if I was to replace x with negative x, would that change the equation? Well, all of my x terms have actually got even powers, so it wouldn't matter if I put, say, 1 or minus 1 as the x value, it wouldn't change the equation. So I can see there definitely should be a line of symmetry in the y-axis, which immediately gets rid of b and e. If I look at the y terms, actually we've got odd powers in the y terms, so we're not going to be able to switch over um, we're not going to have that line of symmetry in the x-axis because of the y not being symmetrical. So we can straight away get rid of d. If you then look at the, the left-hand side, you see the sort of coefficients 1, 4, 6, 4, 1. Mind you, Pascal's triangle. And even if you didn't have 1, 4, 6, 4, 1, it just looks like something that could be a binomial, the expansion of a binomial. And if you look at the fact that the x powers are the biggest x power is twice the biggest y power, you might have a guess at something like this. And actually, if you expand that, you'll see that that is correct, which overall gives us x squared plus y to the 8 equals 1. That means that either x squared plus y equals 1, which implies that y equals 1 minus x squared, or x squared plus y equals minus 1, which means that y equals minus 1 minus x squared. And that tells us straight away that we've got C, because both of these are parabolas that approach negative infinity, so we've got rid of that one, so it has to be C. Again, the things to look out for here: are there any lines of symmetry in the x or y axis, i.e. are x or y even or odd, and can we use a binomial? It's very common for these complicated looking polynomials to be the result of a binomial expansion. Hope that helps.